and then along came AI, that power is estimated to already be eclipsing streaming in the space of 3 years. Remember, streaming probably eclipsed broadcast energy many years ago in terms of its energy consumption and physical internet demands. And now AI has swept through and is cleaning up in terms of pre-procurement of energy. So if you're trying to build out at the moment, be it AI or streaming, your first call is to energy, and you're going to join a long queue.
The magical sustainability recipe for optimizing server use and data center operations is pretty well known. Don't get me wrong, executing it well requires you to be a chef, but the recipe itself is not rocket science. It usually goes something like this. 1. Chase zombies, aka practice instance hygiene. 2nd, don't over-provision, scale wisely up and down. And 3, use a machine at maximum capacity. And by maximum capacity, I mean the capacity up to the threshold where the lifespan of the physical component inside the machine is actually shortened because of overuse. We want to avoid reducing the lifespan of many servers for the sake of avoiding an extra use of one. That being said, I had the pleasure to listen to Dom Robinson's talk 2 times. One in Greenire Paris in 2024 and one in Greenire London this year. In 2025. And each time, I had this haha moment where I realized that this recipe could be challenged when we focus on network, which is how we distribute data, rather than on data center, which is how we compute data at scale. So I asked Dom to join me on the show to talk about the most common misconceptions regarding networks and sustainability. Dom Robinson has a long career in the network and media industry. He has been pioneering in the IP audio and video streaming since his first podcast 30 years ago. He owns several patents in the area as well. And 5 years ago, he co-founded Greening of Streaming, which has been one of the most active NGOs globally in the field of sustainable networking. Welcome to the show, Dom. It's a pleasure to have you with us today.
I hope so. You said it was a pleasure to hear me speak twice. I hope it wasn't a misfortune. That's a good start.
And it was a pleasure, actually, both for me as someone interested in the topic of IT sustainability at large, but also as a conference organizer, because the 2 times you spoke, whether it was in Paris or in London, I could see faces in the audience like, oh, damn it, I've never thought about it this way, because we, and by we, I would say the huge majority of IT folks working mostly on the server side of things, we tend to copy past what we know to other area, one of them being network, whether they're mobile network, landline network, and so on. And when you explain to us that actually there are tons of misconceptions, that's always an eye-opener. So actually, this is maybe where I'd like to start with a first question regarding a potential misconception. As I mentioned, scaling for server hygiene, does it make sense to scale up or down a network architecture to save on energy consumption? Or is it actually feasible?
Always best to go back to first principles and what is a network, and going back to Claude Shannon's famous paper on it, which was the foundation of information theory. He defines signals really well in that system, and it's really difficult for the average internet consumer who uses the internet for a specific purpose to actually really appreciate what the infrastructure does and how it carries all these different use cases. And so on. And so we have all sorts of different demands on network infrastructure. And at its most basic, this idea of not sending a piece of information over a network, therefore uses less energy, is a very, very complex and very fundamental question when you're trying to look at the energy a network uses and therefore correlate that to carbon impact or sustainability impacts and so on. The simplest way to explain it, the way I'd explain, well, I'm not going to put anyone on the spot, but the way I'd explain it to people who need it explained simply is if you have 2 yogurt pots and a piece of string and you run them from your, from one room to another to make a primitive telephone system, if you're speaking, there's obviously some idea that there's energy being transferred by the base of the cup onto the string and out of the other end of the cup to the listener. And so there's a sort of theory that if you stop speaking into the cup, that less energy is sent over the string, if you like. So the molecular forces which hold the string on together still exist. And at its most basic level, when you translate that to the internet, the internet's always on. And what we do is we modulate a signal into different carriers and different address pairs which get information around. But modulating a signal which is always on doesn't change its energy fundamentally. And so correlating data and quantities of data to energy saving is a very simple way to try to attribute energy use to certain things you're using from the network, but it doesn't have its own quantum of energy that you can count. The quantum of energy is the entire system's energy at any one time. So coming back to sort of plain English, not sending information over the internet doesn't mean the internet doesn't use any energy. And so this is the very fundamental and upsetting bit of physics which comes into some conflict with the more abstract modeling that is typically put onto digital services usage when it comes to carbon accounting and sustainability energy measurement. So complicated answer for a starter there.
Yeah, but that's exactly what I wanted you on the show. So that's actually, you pinpoint to another misconceptions that I've sort of flagged, which is there is not really something as idle state consuming no energy for network equipment. This is what you meant by the internet is always on. Am I right or not?
Yeah. So the real energy use is in the baseline of the availability of the network. That's where the energy is burnt, not in its use cycle. The use cycle has a very nominal effect relative to the base load of provisioning the network. So turning a data center on uses most of the energy. Doing nothing, doing a lot with it, fluctuates the energy by a significantly smaller proportion. And given that most infrastructure is over-provisioned in order to deal with the volatile nature of traffic, it's actually questionable whether underutilizing part of the network is more wasteful than overusing a network which is already on, which is, again, a complicated concept if the argument is simply use less data, save the planet. It doesn't work like that. Not in reality, it doesn't work like that.
That's really interesting because there are two things to unpack here. The first one is that actually not using a network doesn't really fluctuate its energy consumption. And a quick question just to understand a bit more in details. Is it all the networks or is it just like optic fiber and mobile network? Would they work the same or not?
So I have to sort of briefly look at each one of them because they've got slightly different characteristics. In the fiber optic case, it's anecdotal evidence. I can't quote anything directly here, but the numbers I have in my head were that a 1 terabit optical network in 2011 could run at about 800 watts. And in 2020, 10 years later, a 10 terabit network can run at 400 watts. So you've got 10 times the capacity for half the power. Okay. Now, that 400 watts is on. So there's always 10 terabits of zeros going, and sometimes you might modulate in some ones to create information. But basically, that network is always on, and it really doesn't matter how much or how little information you modulate into the signal. Copper networks, I think, are easier for people to visualize. And I used to have this very long diagram of all the different energy consumption points in the life cycle of a live stream, like we're recording with today. When you really start breaking it down, it's terrifying because historically you'd have a TV with a plug and you'd receive a signal which was coming from a transmitter some miles away, which might have been burning a few kilowatts of radio energy. But it didn't actually matter if you added more TVs to it. It was a reasonably scalable thing. So it's just the cost of the TV's electricity which you added. In order to add streaming infrastructure, well, it's largely built now in most regions, but in order to add streaming infrastructure, if you walk backwards from your house, you have a router where you have your laptop or your streaming device. You have a router in the corner. You have a 400 watt amplifier at the top of the copper cable if you're on DSL, which is either in a box outside the house or it's on the top of a telegraph pole. You then have green boxes, which are like repeater amplifiers and routers as you move into the IP world, and they might run at 400 watts to multiple kilowatts just in the high street. By the time you get to your exchange, you've probably passed through 3 or 4 of those. Then your exchange is probably sitting at something like in the hundreds of kilowatts. And that makes the connection back to your regional exchange, which will then connect you through lots of branch exchanges back to the peering point where you meet a reflection of the whole thing, which goes all the way to the source of the content. So there are hundreds, if not thousands, of boxes involved in that pathway, and they range from 5 or 10 watts for your domestic router, maybe 30 watts for slightly older ones, right through to kilowatts, and many of them, just to get that signal from me to you right now. There's a lot of infrastructure, and that's always on. It's always waiting for us to use it. It's not something that's turned on demand. The simple way to think of that is it's always on. That's why we can start a call when we want to start a call. Now, if you scale down that network, you start to break it. You just literally you reduce its availability at some level, and that can mean you have to wait. Streams rebuffer, calls don't connect, people can't talk on WhatsApp or whatever it is. Emails don't get through if you get really sort of heavy about that capacity constraint. And people don't use the services. They migrate to somebody who's got better availability if that happens. So demand itself, by the nature of the service, just will cause a movement away from under-provisioning. That has lots of truths for fibre as well. Mobile networks are a slightly different characteristic again. So mobile networks almost invariably in Northern Europe and in the States, North America and in Europe and most developed economies have a fibre to the base of the mast. And we've spoken about fibre already, but once they get into the mast and into the radio access network, you have a variety of switches. There has always been an idea that there would be compute in the radio mast, but there is surprisingly little, really. That despite the movement of network operators to software-defined networking, in practice, network operators find that they like to send lower skilled engineers out to swap out fixed format switches rather than higher skilled engineers to a lot of regional endpoints. It's easier to bring that technical core to an eNode B or the center of a local group of the radio network and have actually a limited amount of compute. So the radio access masts have limited amount of computers in them. But even so, those computers are all talking to each other with 100 gig sort of fiber channel or sometimes Ethernet in their environments. So not using them again doesn't vary a great deal. They have to be powered up to work. So the thing that uses the energy in a radio mast is a transmitter or a transmitter-receiver radio connection. And that's actually not only where the dominant energy is used in a radio mast, but it's also where the signal contention actually happens. It's not in the IP connectivity. It's in the radio spectrum that can connect many phones to that mast. So you can add frequencies, and that will increase the energy on the mast. But it's very easy to add capacity. And it doesn't really cost very much because your dark fibre is, once you start lighting up dark fibre, you can double the capacity on a fibre by adding another wavelength of light. And that's another, as we mentioned a minute ago, 400 watts. So you get to a lot of people with a lot more data, and the real challenge is the spectrum and so on. So long story short, with mobile networks, there have been some projects to turn off quiet mobile networks. and reduce the amount of spectrum traffic on them. There were some reports by a mobile network I won't name, which pointed out that they had reduced 40 kilowatts off their network by quietening the network in sort of overnight periods and so on. That company has 70,000 employees. If all of their employees didn't boil a kettle, they would save 40 kilowatts of energy in that instant. It just to help bring things into proportion about how much energy we're really saving in practice. You're restricting the availability of the primary service that you want, and punishing the users at that point, punishing everybody's access to the service they're paying for, and you're not really saving money in an efficient way. There are many more efficient things to focus on in a business's operations than that scale of improvement. That's not to discount it. Every little helps. I think is an important trope within the sustainability community, and it's very valid. But it's also really important not to market that saving 40 kilowatts on an infrastructure which is using probably terawatts of power is really the right low-hanging fruit that we should be working on if we're going to meet climate accord targets and those sort of objectives.
A quick word about the sponsor of this episode, Resilio. Resilio provides leading data, tools, and professional services to assess and reduce the environmental footprint of tech. As a Green IO listener, Resilio grants you a 1-month free trial access to their Resilio database, a search engine for the footprint of any IT equipment or services. Find the carbon or water footprint for tens of thousands of products in a click, and so much more. The link for this special offer is in the show notes. Full disclosure, I only accept partnership with companies whose services or initiatives I personally support or use myself. As usual, however, I'll let you be your own judge about these products. Okay, so that's a bit counterintuitive because I've heard a lot of people saying, we understand that Wi-Fi and landline network are much more energy efficient. So whenever you back at home, you should turn off the 4G or the 3G or the 5G and use Wi-Fi. And what you're telling me is actually using or not using that much your mobile network doesn't impact that much.
Always moving problems around. The moment you turn your Wi-Fi on and to try to reduce how much energy the mast is using, you've just created 200, 300, maybe tens of thousands of homes which are now running 30 watts extra. So you've moved the problem from the mobile phone's energy bill to the domestic energy bill.
That's pretty much it.
Yeah.
Okay, got it. So I think that's the number one misconception is like network is on, whether it's mobile or optic fiber network. And the real leverage to reduce its energy consumption is not really the degree of use and how much data is transferred by this data. And I guess it comes more to a second misconception that you just mentioned, which is about how network are designed. And you mentioned the word peak. I think this is Romain, who in a previous Green IO talk mentioned that network actually designed for peak capacity, and that's maybe one of the strongest leverage in reducing the consumption of the overall consumption of network. Because, as far as I checked, according to the International Energy Agency, which is, I know, debatable numbers across the academics, but hey,
they're pretty good. I think the IEAs are some of the best. So
I know that the latest production has been debated, but overall, they're pretty strong, very consistent, and they keep on saying that the energy consumption from both mobile and fixed network is still higher than the overall energy consumption of data centers, despite the massive surge that we experienced because of AI, compute, and so on. So these networks, they still use a lot of energy, and to improve their energy efficiency, it's more a question on how we design them and how we go for a peak capacity approach to maybe another one, rather than turning it on or off and using more data. So can you explain a bit more how the network is structured, how much buffer is accounted for potential peak, and how do operators basically operate and maintain their network?
There's a little bit of sort of telecoms history that we have to sort of understand, and it's a little bit more about the commercials of the industry than the technical design and the motives and so on. Nobody knows, apart from the cable owners, how much dark fiber is available on the networks. If we knew how much dark fiber was available, so dark fiber is just glass that's run through a tube between central locations and so on, and it's waiting for someone to connect some optical kit on it and light it up. So dark fiber is sort of the holy grail, the deepest level you can go in before you start really just maintaining tubes and so on. So the dark fiber operators are generally very secretive about how much capacity they've got, because if we all knew that they had almost infinite capacity, then supply and demand would completely bottom out their pricing. And in fact, as massive fiber networks got lit up, especially between 2000 and 2004, what happened was the value of information and the value of data dropped through the floor, and information services that were building themselves around .com models crashed, which was the fundamental of the .com crash. And so similarly, when you get large infrastructure lighting up, it changes economic balances in the telco infrastructures. So it's going to sound very contentious, but there is no shortage of capacity. There was a lot of rumor during some of the biggest streaming spikes we saw were during the pandemic. And there was a lot of talk by very large broadcasters working online that they were reducing the bit rate of their content to save the internet and make sure that people could talk to their loved ones. That's a lot of lovely dressing in terms of marketing speak, but actually what they were doing is retreating from delivering 4K and 8K video online, because it was costing them a lot of money per user, because data is billed by the gigabyte typically, or gigabit per second. It was costing them a lot of money for that distribution, and very few people were watching it. And to having spent years and years chasing the quality game, it was a great moment to say, actually, this is good enough. And to be honest, that was quite a good outcome, because nobody needs 8K on their phone. It's just a ridiculous concept. It's over-engineered and it's expensive because of the way the economics work. Because telecoms efficiency has always been measured in that gigabyte sold or gigabit per second interconnect model, it's always been spoken about as efficiency is reducing your data, because that makes it cheaper to run those surfaces. And in theory, if you can deliver the same quality of service with less data, then you can make more profit. Now, obviously, big telcos get audited, and auditors like to pick up new subjects to sell as reports. And so the big auditors then took their efficiency observations of the economics of telcos and internet services and started going, well, if we could correlate data to energy, then we can just add a column to our existing spreadsheet about data and cost, and go data, cost and energy, and there's another £1 million sustainability report. So the path of least resistance, and the thing that the sustainability industry, as it became an industry, wanted to pick up and run with, was easy reports selling gigabyte translations to carbon, which then we can sell for £1 million reports and say, oh, just reduce your data and look, your carbon reporting suddenly looks better. But in fact, the networks don't work like that. If you don't send the gigabytes of data over a network, you don't get charged, but you also make no difference to the energy, as we spoke about earlier. So therein lies, 100 different frogs in the box, and it's very difficult to really consistently grab any of them, but they do form a fairly clear picture that scale of the network and use of the network are independent when it comes to energy.
You're telling me two things. Once again, it's the usual tale in the sustainability world of complete disconnection between what we measure in the economic world and what we measure in the physical world, because we decided to price gigabyte as a mean of measuring the value of a network. We decided that, hey, it should have also the same physical impact, but that's two completely different things. Actually, a sound, or I would say a more sustainable business model for operator and provider of these dark fibers that you mentioned would be to charge a package rather than a volume, because that's actually their cost structure is flat based, and then you've got incomes that are volatile and they face fixed cost base. So this is really something of a twist to connect things that are not connected.
It's probably worth dropping mention of a technology I have a particular fascination for, called multicasting, IP multicasting, which is kind of baked into the internet, and it exists as a technique by which one person can send the same packet to multiple destinations. So it was originally invented in 1988 by a chap called Steve Deering. He was one of the sort of big granddaddies of the internet. And it was originally called selective broadcast. And so it's the equivalent of broadcasting over a network. You've got this idea that you can send a radio signal down a wire and attach multiple receivers to tune into that signal, a bit like running a cable signal through your house. But multicast is fascinating technology, which is actually available in the internet. And it needs some particular configuration to turn it on, which has never been centrally coordinated, so it's not happened in a clean way. But it's there. I built my first CDN in 2000, was predicated on multicast delivery, and it gives you the most scalable way to deliver live traffic. Live traffic tends to be the point where you have a crush, where everybody wants to watch the Super Bowl or the World Cup final online. You have a crush and you get a peak of traffic, and the network has to be able to handle that peak and is scaled to meet that demand. So multicast was always deemed to be a way to flatten those peaks, which would have reduced the need to build very big networks. The problem is that because multicast isn't configured and widely available as a native capability of the internet, as an interim measure, people invented web servers and media servers and technologies like that to relay the signal through the network. Those organizations now carry most of the traffic that we watch and consume when we're streaming video. And they're very big players, and they're the biggest buyers of the telcos. They don't really have much motivation to cannibalize their revenues and make their networks smaller and cheaper and pass that on to the end user. Now they're making that money. They're only really interested in growth. And that's the nature of business. So multicast could make those unicast CDNs significantly smaller, or at least deal with peaks better. But somebody would lose a unicast revenue. And when you're charging a broadcaster to deliver every byte of content to every user separately, why would you turn that into a bill to deliver one packet to everyone simultaneously? And that would decimate your revenues. So there isn't really a commercial motivation to make the network efficient in that sense. Multicast doesn't necessarily relate to energy unless it brings down the peak size of the network.
Yeah, I think it's time to wrap up, because, and first of all, these big players, let's name it, the Akamai, Cloudflare, the being CDN providers. So this is the companies we're talking to. And if I follow all the insights that you've already shared, I reach a very strange conclusion, which is, the networks as it is today is completely over-provisioned because it has been provisioned for peak capacity. And you're telling me that actually there is a lot of room actually for growth, and that if I understand it well, we could literally decide to pause any new network investment for the next 10 years. And except for very small marginal situation, things will work pretty well.
So just to confuse the table even more, going back to that optic fiber example, we can now get 10 times as much traffic through half the energy in that optic fiber example. One of the curious things about information technology is there are two dynamics going on. Over time, we use more, therefore we install more, and every time we install, we step up the energy use. Doesn't gradually increase with the users, it steps up with the anticipated users.
Yeah, absolutely. It's a step by step. It's really how you dimension your network that will give you the overall energy consumption. So it's really a question about pausing network investments, or actually reducing or spreading those investments. But no,
No, it's more complicated than that. You've got to think of the tungsten light bulb and the LED light bulb examples. Um, IT and technology tends to improve its efficiency over time. And so a 10-year-old network uses twice as much energy to do a tenth of the content as a modern network. And in fact, driving revenue into the telcos so that they can invest in more energy efficient content because it reduces their bottom line costs means that actually driving traffic, driving telco revenue, and driving investment into new technology quite often outruns the energy lost by not doing anything and not do it. So there's a very complicated calculation where you have to look at the embedded carbon, the embodied carbon in the network infrastructure, and how you can recycle that, take that network equipment out and upgrade it for more efficient switches, more efficient routers. And if you can get that balance right, then actually a network upgrade can increase the capacity, increase the revenue earning potential to do R&D and invest in renewable power and do those things while actually reducing the operational energy in the moment. The hardest complication comes in how you frame both of these. We had a paper last year where we spent a lot of time separating the distinction between attributional life cycle assessment, which I would sort of ring fence in this context as being this correlation of a gigabyte to a kilogram of carbon. That's an attributional model. It's very different to a consequential life cycle assessment, which actually works out whether you really reduce the carbon footprint, the energy footprint of the infrastructure. One of them reduces your responsibility or your blame. The other one actually makes a difference to the planet. We're very caught up in we're very caught up in attributional life cycle models because they always get attributed to the diaspora, the mass of people, to say everybody gets involved and we save the planet together, whereas in fact it's the telco that makes the decision about whether they buy 60 megawatts of coal power or renewable power.
And this is the telco who are deciding not to deploy MCP, which would massively reduce the need to extra investment and so extra energy consumption in the next years.
And a lot of what we're seeing at the moment with the explosion of the topic around AI data centers in particular, underneath the hood, it's all hedging on energy.
If you're enjoying this episode, help us get more responsible technologists on board. Please rate the podcast 5 stars on Apple Podcasts, Spotify, or Deezer, and drop us a comment on YouTube. And now, back to our episode. And this all connects to a third misconception that you already told me about, which is, does it really make sense to measure carbon per gigabyte? And I don't know if you remember this massive controversy between the SHIFT project, the International Energy Agency, and Carbon Brief about how you measure 1 hour of video streaming. And it was interesting because the discussions helped the debate to gain in maturity. Still, at the end, the order of magnitude was still between 4 and 7, which is pretty significant. And listening to you, and this is really my question to you, is does it make sense actually to willing measure things that way? And is it actually what you've just mentioned about sort of us leaning toward the attributional aspect of things, because that's easier to say to everyone, hey, if you're watching 1 hour of video, this is how much carbon you emit, rather than going the hard way, which is a consequential aspect of things.
One of the reasons I kicked off greening and streaming was the SHIFT report was becoming a very topical discussion, and the numbers didn't make any sense to me. And I'd spent 30 years in the streaming industry building content delivery networks at global scale. So I kind of fancied myself as having a reasonable idea of what was physically going on in these networks. And this immediate miscorrelation between energy or the use cycle of these networks sort of rang an alarm bell. So it was very instrumental in getting the discussion going. The problem is that discussion became very loud and dominated thinking, and the outcomes of that discussion then fed into the sort of corpus of intellectual and academic work, and actually then echo chambered around and amplified itself, but was never tested by engineers. And still to this day, Greening of Streaming's fundamental mission has been to go and get some primary data. We thought it was going to be easy to ask data centers and networks, companies and organizations that were becoming our member to give us information. And still to this day, we've never had any. We had some very high level estimates, but tap them hard, and then there's another layer of technology which wasn't included in the picture. So trying to get that real energy measurement done is fundamental to Greening of Streaming's existence. And it's insanely hard. If we wanted to go and make up a report about carbon footprint per user, I'm sure people would spend thousands and thousands and thousands of pounds on our reports, but we don't. We want to actually have a repeatable scientific experiment which can say, if we change the luminance of this video, if we change the encoding format of this video, if we do the things that we're empowered to do as streaming operators to the video process, will it make an environmental impact or not? We're still struggling to get the resource out of the industry to really get those projects up to scale where we can make an informed decision. And without them, all of the other reports you're reading are conjectural. They are done on microscopic lab tests which are completely out of context, and generally the output has fit the agenda of going, it's all the user's fault, don't you know, just tell them to turn it off, which is not a realistic view when you have most of the population are now migrating from legacy broadcast onto streaming as their go-to content consumption model. It's just too optimistic to think that we can just turn that off. And so we have to work with it. We have to change how the infrastructure is put in place. We have to go back to the fundamentals.
I think this is a good old, I would say, classical PR exercise from the tobacco industry or the arm industry, or the weapon industry in the US that blame the user. That's all the user decision and fault rather than the infrastructure and people actually making the decision on whether, as you mentioned, turn on or off a cold power.
Sorry, just to interrupt there, one thing that I think is very important to emphasize is, unlike weapons control and so on, we can very instantly get energy information out of companies. They have energy bills. Public companies should have to disclose their quarterly energy consumption. That would instantly let you correlate their business success and growth to their energy. Now, it's that regulation is now a pipe dream, I think, under the current world order. But that it is that simple to understand what your energy footprint is as a company. Look at your energy bill. It's there.
I recall that the CSRD, despite having seriously watered down, will still help us because with telco, we're talking about so big companies that actually they will still fall under the scope of CSRD in Europe. So we might start to see this correlation, as you mentioned, but the problem is, even if CSRD reports quite in details, they're so big that then it's not always easy to allocate.
They're so confused at the moment and emerging as a science that they just obfuscate everything. If I knew how many terawatts BT was burning on my fibre line, and I knew that my competing telco was burning half that and delivering the same service, and I wanted to make an environmental decision, doing that would save 50% of the telco's energy, and it would make it a competitive marker by which the telcos would then improve their sales strategy. And it doesn't take any great reporting or calculation. It's just a bottom line number, which is, they get an invoice every 15 minutes, basically. We know what that data is. So this is not a hard challenge.
Very fair point. And Dom, I wanted to bounce back on something you mentioned, like luminescence. And it might not be a misconception, but more a blind angle, is that are you actually talking about eco-designing video and the content we stream? Because that's something that we talk a lot about websites and so on. But you mentioned Greening of Streaming trying to measure these sort of things. So did I understand you right?
One of the oft-cited assumptions is that all the energy is not used by the networks. It's used by the consumers with their TVs and their routers and their handheld devices. And hey, what control does the telco have apart from specifying the technology in the first place and defining what manufacturers are supported by standards interoperation and so on? I think they have a lot to do with it myself, but essentially we pass that responsibility to the consumer again. So, and Ben, who's now running Greening and Streaming, and I have endlessly debated whether the fact that there's a huge amount of big iron telco infrastructure that's on 24/7 hours a day, waiting for me to turn on Peppa Pig for my kid to watch it for half an hour. The weighting is heavily into the telco camp, actually. But Ben rightly points out that we can feel and look at and touch and see the TVs and screens being used. So we need to understand them. So we do measure them. Decoding content has almost no effect on the machine, surprisingly, because they use signal processors which are totally attuned to the standards that they can decode, and they use minimal wattage in most scenarios. But what does jump around the energy use in the home is the brightness of the screen. And so the backlight behind the panel in your TV is usually really one of the hottest devices other than your fridge and cooker in the house. An average modern TV, when it's on a black screen, maybe uses I'm just picking some random numbers for sense of proportion here, maybe uses 30 watts or thereabouts. But the same TV, when you're looking at a pure white screen, may use 180 watts. So what does that mean for the user? Yeah, so what does that mean for the user? If you have it in sport mode, ultra bright, and you have a very bright room with that TV on, as you might be if you're in a dark room where the brightness automatically dims on most TVs and you're watching a dark piece of content. So I think there is a lot of work to be done around luminance. That is also a place where the content creator might think about playing. Certainly, electronic program guides are a hot target. So there's my TV at home has a pink screensaver which comes up from the manufacturer. I'm sure you're all familiar with it. Scrolling Cities screensaver. I remember hearing the CEO being very proud that lit up the streets of his local city at night. Through all the open windows with all the devices just left on their screensavers. If he had a dark mode or a black screensaver, he would probably be maybe halving the energy use of all of that dead time. Obviously, it'd be better if people turned their TVs off when they weren't watching them. But electronic program guides and screensavers being in dark mode can actually, on a mass scale, make a real difference, and I mean a real difference in terawatts of power globally. If you want to go the full hog and think about that as part of your program making, it is possible with new systems like Movie Maker mode, I think it's called Film Maker mode, Movie Maker mode, to pass signaling in the video that jumps outside of the media player and actually changes the brightness of the TV settings. That could be very interesting as a long-term strategy if your streaming service provider could go to, not just go to their screensaver or their "Are you still watching" page, but could also go, "We haven't heard from you for a bit, so we're going to dim the brightness right down. In fact, we're just going to turn your screen off until you do something now." TVs that are just left on in the background, digital signage devices and so on, if you could dim the brightness when there's no movement in front of them without adding a huge amount of energy in terms of trying to compute whether there's movement in front of them, that would be. And the other final comment on that is we approach this, a lot of early talk about sustainability in the TV delivery business talked about green buttons, where the user, if they wanted to be sustainability minded, could switch into a green mode where the brightness would be dimmed, it would request lower frame rates and so on and so forth. I challenge the industry to default the mode to green and actually present an orange button where you go, actually, I want to watch Lord of the Rings with full HDR, or I want to watch the latest sporting event in highest frame rate. I'll press the gold button now and have to opt in. Right, and that's great, because I don't mind if somebody's got UHD for their football game that they're a fan of, and that's the primary reason why they got the TV. That's IT being used for its full use case, and we should have the capability to do that. But by default, when my kid is crawling around watching Peppa Pig, they don't need 8K 120 frames a second at full brightness. They just need a few funny sounds and some moving blobs. Do you know what I mean? And I think that once the kids can learn how to press the orange button and go, Dad, I want to watch Peppa Pig in 4K, and it matters to them, okay, they've made that choice. But by default, we tend to push the 4K.
Yeah, I seriously doubt this. But that's a very fair point that you've mentioned, that the by default mode should be green, and we run countless of sustainable designers arguing for this, because that what makes the most sense. So I think we've got almost a force, not misconception, but I would say potential leads. And I know that we're already running a bit out of time, but I guess there is a topic that we cannot not talk about, which is obviously AI. And actually, to introduce the topic, I've got a fun fact, which is that I didn't know, and I just learned today by quickly reviewing your LinkedIn profile, that you graduated in 1994 with an MSc in my beloved University of Sussex, where I spent a full year in 2000. So we are alumni.
I didn't graduate, actually. I have to hold my hand up. I didn't complete the course because I had a startup.
So let's pretend. Let's pretend we're alumni, but that's actually not the most important information here. What is interesting is what you studied 32 years ago, which was AI. It was an MC on AI. So it has been 32 years now that you've been working on this topic.
And astrophysics.
And astrophysics.
And astrophysics.
Yeah. That's for sure. I don't know which one you use the most.
I read more about astrophysics these days, but I seem to be writing and talking about AI a lot more.
I guess so. So AI, because obviously the energy consumption of data center has been under a lot of spotlight. This consumption is exploding because of the massive compute needs for training the models. But what about the networks? And just to introduce my question, I recently heard Seva Weiner, a product director at G-Core, argue that the surge in inference is changing how the networks cope with data transfer. And that's quite funny, because he talked about CDN exactly as you did. Like, the surge in video streaming has required CDN to be deployed everywhere. Well, now we know that actually with MCP, we could use way less CDN, but hey, that's a different story that you already mentioned. For him, networks must now distribute compute power to handle real-time AI interactions. And that changes the very definition of edge for him. Edge is now where sufficient power and cooling can be secured rather than just a physical proximity. So that really, I thought his ideas to be quite interesting, and I'd love your reaction to that. And of course, could you explain the greening of streaming position, especially following the position paper it's Language Lab released this January, because everything, I guess, is sort of related. So a long introduction, and I expect not so short answer from you.
I'll try and keep it short. Okay. Let's talk about the infrastructure of AI first of all. The very first conversation I had, which led to exploring the space, discovering the shift report, and kicking greening and streaming off, the very first conversation I had, I was running a series of conferences called the Content Delivery Summit. I took over from a chap called Dan Rayburn, who'd been running it for 20 years in the States. And I took it over just as the pandemic kicked in, actually, and so did 3 years of running it online. As part of that, one of the key speakers I brought on board was a chap who'd been part of the fiber deployments that ran transoceanic fiber deployments. There were the Fagan companies, the big GAFAN, Fagan, however you want to group that those guys had all teamed up and decided to run their own fibers over the oceans because they were sick of buying from third parties, basically. So they teamed up, $30 billion rollouts, fiber from west coast of the States to Japan, to China, to Asia, wherever it may be. And I spoke to him about where he thought the bottlenecks in content delivery were, and he said, "Oh, the bottlenecks are in power." And I'd thought about the bottlenecks being a streaming challenge and how we put caches in and where we should put the largest caches and buy the right peerings and get the right telecoms companies. And no, it was access to power. If you're going to land a fiber on a coastline, you need a cable landing station, which typically requires 15 to 30 megawatts of power. And it's near enough fiber trunk routing to be useful. And the other end of that then needs to be at your major interconnect. which typically becomes a carrier hotel. So it has a lot of routers and switches, but also an increasing amount of cloud infrastructure at or very close to it, close enough that from the municipality's point of view, it's the same location in terms of power. And in order to future size those, you want to be looking to build your data centers at 150 megawatt. So big, fairly big data centers. So finding a place where you've got two energy providers, so you don't get locked into one, who can provide you 150 megawatts that's also near fiber trunk from the coast to you and near a metropolitan area where you can find customers, is gold dust. And that was a problem in 2018, 2017, so before the AI boom kicked in. And really the biggest people going out and buying access to those at the time were the clouds, emerging clouds, and CDNs. CDNs, don't forget, have been the cloud for 20 years before the cloud emerged. It was huge distributed layer 4 computing. We learned how to do virtualization at scale long before any of the public clouds put a spade in the ground. And so we know about access to power on that level, but once you're buying it through the carriers, they were the ones who actually dealt with the procurement process and the build out and so on. So when you fast forward another 3 years, then there was a big sustainability debate, and organizations rushed out to go and pre-procure any forthcoming renewable power because that was seen to be a better purchase politically and so on. At which point the CDNs weren't as big as the telcos, and they started to struggle to buy enough energy to build their micro pops because data centers were already being built out but close to the green power. And then along came AI, and in this, as you'll see in the paper, which is now on the Reading and Streaming website, that power is estimated to already be eclipsing streaming in the space of 3 years. Remember, streaming probably eclipsed broadcast energy many years ago in terms of its energy consumption and physical internet demands, and now AI has swept through and is cleaning up in terms of pre-procurement of energy. So if you're trying to build out at the moment, be it AI or streaming, your first call is to energy. And you're going to join a long queue. And those big companies are buying stuff before it's rolled out. So at the moment, you can't buy energy in Northern Europe for a 150 megawatt plant because all the AI businesses have already gone in and pre-purchased it. So good luck in building a green hospital at the moment if you want to power it with green energy because it's already been bought. And that money with which it's already been bought is what's investing in bringing it. So it's a self-edifying sort of corner of things. And that's a real challenge. I think that is a real social problem with the runaway of AI's power demand at the moment. In terms of what effect will that have on the networks themselves, what effect will AI have? So you've got to remember that streaming uses a lot of network. One video running for an hour is going to be hundreds of copies of the Encyclopedia Britannica. It's more information than we can transfer in any other way, really. So machine-to-machine communication around AI, it's not really going to emerge in the same way that 5G never really discovered autonomous vehicle information flowing in, because autonomous vehicles are strangely autonomous. They don't really need the network to work. So
hopefully so.
It can't be mission critical. Otherwise everyone would sort of stop when they went through a tunnel. Yes, there is a lot of new machine to machine network data going around between AIs and between agents and so on and so forth. Are they streaming a lot of video to each other? Some of them are doing AI generation, but relative to how much we stream to on a single evening for people watching iPlayer, Netflix, Sky Now, that sort of thing, a minute or two of the streaming is a day or two of machine to machine communication, and so on. So, the big cost is in the training and in building the compute environments for that trading and that use of the AI.
Now, that's interesting because, of course, you're mentioning AI, and by AI, let's name it more precisely, Gen AI, and mostly the ones powered by large LLM. Um, so machine to machine, not that big. Clearly dwarfs by streaming. So for once, there is one industry in IT which says, well, AI will not impact us that much. But I see two caveats to this. The first one is, as you said, the pressure on energy being available and everything else. So it sort of connects to what I mentioned earlier about edge computing is now more about where you can actually lend power to deliver things rather than just being close to your customers. But there is also a trend today to video related AI producing video and so on. Does it have a significant impact? Could it have a significant impact, or is it actually still marginal because the video is just a few megabytes?
It's sort of a question where you've got to split streaming a little bit. Broadcast typically split itself into production and distribution, and really streaming has much the same. And really what we're talking about there is AI being involved in the production cycle and generating more content. But we're not generating more. We're not really generating more viewers because we're generating more content. We're just presenting new content to the same viewers. So the distribution really isn't going to get that affected. But the production side, yeah, of course, if you go and use an entire server farm to make 8K 120 frames a second sporting videos of cats playing football or whatever it is, it's going to use energy which is very directly in the same way as in the video streaming industry. There's been a trend to create multiple encodings of any video for different formats and different reach. At a point, you get diminishing returns on that. And so those models which have been underpinned by venture capital, so are coming out to us users very cheap, if not free, they're soon going to get their investors saying, I'd like to see a return on my investment now, please. And I use AI in coding and stuff like that. My bill last summer was monthly £20 a month. And then the billing model changed from per prompt to per token. And now my billing, I have to put caps on it because the same use case, the same experience has gone up by an order of magnitude. And that will continue. So where we can get free fake video, deep fake video type things being, sort of toys for people to play with at the moment, sooner or later people are going to go, okay, enough land grab, that's just costing me an insane amount of money. I'm going to capitulate on that and start to charge properly, which will self-regulate the demand a little bit.
That's what I expect as well. And some use cases will stand, obviously, especially for development, software engineering, and so on. That makes total sense, and a lot of them will be dropped. Maybe to close our discussion before we open it again when we will meet, I don't know, in London or elsewhere. So what about the position of the Greening of Streaming Language Lab on AI? What could you tell us about it?
Everyone last year was saying, what's Greening of Streaming's position on AI? As if they knew something that we didn't, which is kind of entertaining. So streaming is a little bit more of a known thing, and there's a lot of thought and discipline in what we do, which I think translates to trying to understand and measure the impacts of AI and so on. And so I think we needed a position paper on the topic. Naturally, when you put out anything as a trade association, everybody just wants to go straight to the data and the numbers. And we as Greening and Streaming, we've been very hard and fast that we only put out numbers that we can scientifically go and prove repeatedly. We don't try and pick up anecdotal data and turn it into yet another ChatGPT session that sounds like new data. So we were very terse about what data we both commented on and used. Again, we tend to return to the IEA because they've got fairly extensive methodologies. They've obviously got their own interests, but they've got fairly extensive methodologies, and of any group, we are talking, I think, 20, 30 levels from memory. I haven't got the paper in front of me at the moment, sorry. But we're sort of coming on for 70 to 80 terawatt hours for streaming, and about half to double again, so 100 to 150 terawatt hours for AI energy compute costs over as an annual sort of finger in the air figure. And I might have got those wrong, but the order of magnitude comparison I think is important. We've got to remember AI did that in 4 years. Streaming did it in 15. So it's definitely it's definitely the pony to watch at the moment. But the overall, we also felt that we had to look at where AI impacts the streaming workflow. So it's not just how do we compare the industries, but how do they interoperate? And AI is instantly becoming used in not just content generation, but in workflow orchestration, in network optimization, and so on and so forth. The optimization brigade always march down the street claiming that we can optimize everything to the point that it doesn't use any energy. I think that's a little optimistic,
Really?
but it's certainly useful for big data. Machine learning and tensors are great for analyzing huge data sets very quickly, much better than people, and that can lead to really interesting observations and inferences. So there is some harmony, there is some conflict, and there is definitely something that's having an impact of the same order of magnitude as streaming. I'm very reluctant to compare that to real world things because I just don't feel like we've got the data. The one number that I think is I like to keep in my head because it helps scale things. The BT network in the UK uses about somewhere between 1 and 1.5 terawatt hours of electricity. Terawatts, instantaneous power, terawatts of electricity. And the London Metropolitan Underground electrical subway, the tube, uses roughly the same amount of energy. So just to give you a picture of this invisible energy use that is the network, that's a useful number to have in mind. And so it's totally invisible. It's often forgotten about, and it's very difficult to really, as a user, make a difference to how much energy is used on that network. But it's not to be forgotten. And AI is definitely the poster boy of the moment. And streaming had that, maybe as the pandemic happened, everyone suddenly discovered that YouTube was for grown-ups as well. The reality is AI has definitely moved up alongside us at the table. It's a key part of that worldwide infrastructure, and it's something that if we're going to evolve IT and networks in a sort of responsible way, we should equally try to understand how much energy is going into the data centers for AI applications, as we are and have been doing for a decade for half a decade in greening and streaming. They're cousins
for streaming. Yeah, okay, the cousin problem, but yet they don't impact the network itself the same way. Because what I took from your report is that, hey, regarding distribution, not such a big deal. Regarding content, yeah, definitely. But as you said, with maybe at some point cap mechanism that will appear when actually investors will reclaim their money. And I think that was really honest from greening of streaming, not to ride the wave of AI, saying, oh, of course, AI is a massive issue for us. AI is everything. AI, bring me the money because of AI. No, actually, no. I mean, you stay focused on what you do, and that's really good.
Yeah, and we've also we are a trade industry, and I don't want to sort of pretend that we're going to pull the wool over people's eyes. My own software company, we are deeply involved with AI in the live workflow. It's an inevitability of our industry and of the state of the world, really. We'd be in a denialist sort of mode to say we are, AI can solve everything, AI can break everything. It's going to be, well, not least, having studied it 30 years ago, I have very strong opinions, which is for another podcast, but very strong opinions about the use of the term AI. We're only passing the Turing test because the users have become more stupid.
Okay, we're definitely going to have to do another podcast about this sentence. But as you say, that was not the main focus here. And we said, okay, we're going to keep it short and straight to the point, or the most common misconceptions about network energy consumption and environmental impact. So actually, I think we achieved half of the job because we covered the energy consumption of network and how it's specific and absolutely not related to how much do we use it, the way it is architecture, and it's more business driven than actually technically driven or even physically driven. With its peak capacity, we discussed crazy things like, we could actually design video, and that could have a massive impact, and the fact that how much carbon is emitted by, I don't know, 1 gigabyte, 1 megabyte, whatever, is really a bias to attributional model rather than consequential analysis. And of course, we talked about AI, and I'm pretty pleased to say, okay, regarding the network, that will not be a massive deal, except for this struggle to access energy, which is and especially green energy, or I would say more precisely low carbon energy, which is in a very short supply at the moment. So I think pretty cool. We covered a lot. We didn't keep it short because and this is what I love talking to you. You enter into a lot of details because you elaborate your answer, and I can literally feel the level of knowledge in every answer you provided. So thanks a lot for this. That was really a pleasure to have you on the show.
Please do invite your listeners to check out the greeningofstreaming.org website. There's publications on there which, and get involved with us. Talk to Ben.
I will. And as usual, all the links, including obviously links to the latest Greening of Streaming reports, will be on the show notes. Dom, one last question to reach out to you. Is it LinkedIn? Is it something else?
Yeah, I was on LinkedIn. And for Greening of Streaming, reach out to Ben Schwartz, who's running it now. I couldn't wear too many hats, so I had to leave him, and he's doing an amazing job with it now. So good. Reach out to greeningofstreaming.org. Ben's contacts are on there, and of course, link in with me.
Excellent. Well, talk to you soon, and thanks a lot for joining. Thank you for listening to this Green.io episode. Because accessible and transparent information is in the DNA of Green.io, all the references mentioned in this episode are in the show notes. More information and the full transcript can also be found on our website, greenio.tech. Huge thanks to everyone who made this episode possible, with a special mention to our partner, Good Gosh Media, and our executive producer, Russell Baker. And of course, you, my dear fellow responsible technologists. Let's keep on building a greener digital world together.
One bite at a time.